Hi everyone, I'm Leanne. Today I'll be demonstrating a double integral problem that's commonly found in calculus. This one specifically focuses on finding the volume of a shape when given its height and its base. This problem reads, find the volume of the solid bounded above by the surface z, or f of x, y is equal to 2x squared y, and below by the plane region bounded by the graphs of y equals x and y equals x squared. So the first step when looking at this problem, you want to get a visual of the base. So I'm just going to draw the base right here on an xy plane. A little bigger. So the first one is y equals to x, and that's just a straight line from the origin. And the second one is y equals to x squared, which is a parabola. And I will just be drawing the part we need to look at. And I'm going to label both lines. Next, we need to find the two x points that we will be evaluating in the integral. And I'm going to find it by using these two equations. And y equals to x squared. So it's given that y equals to x, so I'm just going to put this into the second equation and solve for x. And to make this 0, x has to equal to 0. Or x has to equal to 1. So once you've got these 2 points, go ahead and write the double integral. And always on the outside goes x, and we're going to be evaluating it from x equals to 0 to x equals to 1. And y, we're going to be evaluating it from the bottom graph, which is y equals to x squared, and the top graph, which is y equals to x. And inside, we're going to put the height, and of course dy dx. So first we want to take out the integral and evaluate it with respects to y. Evaluate it from y equals to x squared, y equals to x. Go ahead and integrate it with respects to y, so 2x squared is seen as a constant, and y turns into y squared over 2, evaluated from y equals to x squared to y equals to x. Here the 2 cancels out, so it's equal to x squared, y squared. Go ahead and rewrite your evaluation points. And then go ahead and plug it in. Remember, the second point always goes first. Go ahead and simplify. Further, it can go to x to the 4th. Minus x to the 6th. And this answer will be inputted when we integrate with respects to x. So go ahead and rewrite your x, and it goes in place right here. Oops. Dx. And go ahead and integrate. X to the 5th over 5 minus x to the 7th over 7, evaluated from x equals to 0 and x equals to 1. Go ahead and plug it in. Remember, the second point goes first. It's going to be 1 to the 5th over 5 minus 1 to the 7th over 7 minus input of the second point, which is 0 to the 5th over 5 minus 0 to the 7th over 7. Clearly this cancels out to 0, so we're just gonna rewrite this. 1 over 5 minus 1 over 7. And keep solving for this, and that's gonna be 7 minus 5 over 35, which is equal to 2 over 35. And 2/35 is the units of volume of this solid. Thank you for watching, and I hope it helped.